All right, back with the second part of special right triangles. This one is called the 30, 60, 90 right triangle. Love this triangle. It's basically, like if I said, what's this derived from? It's derived from an equilateral triangle. So I'd be like, all right, equilateral triangle. What's true about an equilateral triangle? So, Skippy in the back. What's true about an equilateral triangle? All the sides are congruent. Thank you. So all the sides are the same length. Bam, bam, bam. We also noted that when we talked about equilateral triangle, it was also equiangular. We said equilateral implies equiangular, equiangular implies equilateral. The fact that it's also equiangular, all the angles add up to 180, we could therefore conclude all the angles in here had to be 60. So you might be saying, why is this a special right triangle? There's no right triangle there. Can I make a right triangle in here? Well, what kind of segment could I drop from a vertex to the opposite side that would make a right triangle? An altitude. So we're going to drop the tube. No, not drop the tube. We're going to drop the altitude. So from here, drop that down, right angle. Now I've got two right triangles, 60, 90, 60, 90. What do these have to be? There's a couple ways we can conclude that. They have to add up to 180. It also, these triangles are congruent, and I knew that angle was 60, 30, and 30. So now I have a 30, 60, 90 right triangle. Let's make this C. Why am I making it C? It's the hypotenuse, right? We've been using that term as general as the hypotenuse. Now I have two legs. One of them we're going to refer to as the short leg. The shortest side of a triangle is always opposite the smallest angle. So I got short leg, I got long leg, and I have the hypotenuse, the longest side in a right triangle. Now, if I said this is the short leg, I'm going to call it A. This is the long leg, I'm going to call it B. That's A. This piece has to be A. What do they add up to? C. So what is C equal to? 2 A's. So there's one relationship that I can look at. The hypotenuse is equal to 2 times the short leg. So if I know the short leg's 4, guess what the hypotenuse is? 2 times 4 is 8. If the short leg's the square root of 5, guess what the hypotenuse is? 2 times the square root of 5. Again, what if I wanted to get backwards? If I multiply by root 2 to get to the hypotenuse, I can divide by root 2 to get back to the short leg, So if that was 16, the short leg's 8. If that's, 3 root 2, this is 3 root 2 divided by 2. I like to think of the short leg as sort of like base. When you were playing a game, I can remember playing games when I was little, and it was always like, where's home base? You got to get to home base. You got to guard home base. You either started at home base or you tried to get back to home base. In this case, when we look at the 30, 60, 90 triangle, we either want to start with the short leg or get back to the short leg. So if I start with the short leg, I can multiply by 2 to get to the hypotenuse. I can divide by 2 to get back to the short leg. Now let's look at how could I get to the long leg. So one equation, C equals 2A. We're going to use that. Let me just erase the other half of this now. So now we're just looking at our 30, 60, 90. I can use Pythagorean's theorem here, right? Again, you gotta love Pythagoras. A squared plus B squared equals C squared. It's like I almost forgot it for a second. It's scary. No. But now, we want to solve this for B, but I want to try and keep it rather simple, right? I don't have too many variables in here. I want to keep everything in terms of the short leg, the base. What is C equal to? 2A. We just figured it out up there. So I could rewrite this as A squared plus B squared equals 2A squared. Now, let's square this and then solve this thing for B. A squared plus B squared equals, well, when I square this, I got to square both terms in here. So that's going to give me 4A squared. Subtract an A squared from both sides. 4A squared minus 1A squared leaves me with 3A squared. And then if I said, solve this for B, just take the square root of both sides, guess what B equals? Square root of 3, can't take it. Square root of A squared, can take it. And A pops out. So the long leg is equal to the short leg times root 3. So again, if I look at this diagram up here, if I know the short leg, multiply by 2 to get to the hypotenuse, multiply by root 3 to get to the long leg. If they give me this, I'm dividing by 2 and then multiplying by root 3. If they give me the short leg, or I'm sorry, the long leg, I would divide by root 3 to get back to the short leg and then multiply by 2. So let me just come up with a couple problems to take a look at. Um, so we'll start off basic. Let's suppose we know the hypotenuse is 12. So again, short leg is where? Opposite the 30-degree angle. So I want to get back to the short leg first, and then I want to get to the long leg. If I know these two things are true, you may want to. Now the problem, I don't want to say the problem is, but most problems are going to give you like an X and a Y to solve for X and Y. They're not going to tell you what's the short leg. So you may want to be like, hey, there's C, there's A, and there's B. So if I know C, pick the only formula with a C in it. And I'm just going to substitute in here. 12 equals 2 times A. Let's solve that for A. Divide both sides by 2. A equals 6. Now I want to find out what B is. Pick the other formula that has a B in it. B equals A root 3. We just said A was 6. Guess what B is? 6 root 3. So you can get rather quickly around in a problem if you know one side. You can get the other two sides very quickly if you know these two relationships. That's the beauty of these special right triangles. You're going to see these pop up again when we do area of regular polygons. You know, we're going to see it in an equilateral triangle. We're going to see it in a regular hexagon. And again, these properties of 30, 60, 90, and 45, 45, 90 come back to help you when you get into the unit circle in pre-cal. So hopefully this video helps you. You know, again, we're going to spend tomorrow just doing more problems with this. But if I know one side, I can jump around to the other two sides rather quickly.